Hello, Fibe Hackathon. We have done a project, and the project is about credit score and risk analysis of various users or customers in a bank. A credit score is a three-digit number from 300 to 900, just used to determine the credit worthiness of an individual. So the main aim we know the main aim of the project is to create a robust machine learning model to predict which individuals are most likely to default on their loans based on the historical loan repayment behaviors and transactional activities. So we have followed so many following process, which we know the exploratory data analysis to model evaluation. So at first, we know we will mount the drive and read the CSV file. We get the data. As we know, the feature variables are like 5,000, and this is the target variable. As we know, in the submission file, we have to make it in a format of target, predicted, and predictor probability. So we will go on with that. So at first, let's see. This is a df dot shape. We'll get the shape, and df is equal to df. This will drop some id. Before looking into it, let's see what's credit analysis according to it, so we can see the process. This is credit analysis, and let's keep a slideshow. Wait, yeah. As you can see, it's a machine learning. The machine learning model has these following contents, and we know the team, which is Mari Sai Surya. I'm the leader. Vemla Vivek, who created the machine learning model, and Nagendra Kamesh, who created the PPT. So the machine learning model is developed by a team, and we are going to we have used so many technologies like NumPy, Pandas, Dask, sklearn, and Matplotlib. Um, so as we know, step one, step two, feature engineerings, model selection, model training, and model evaluation. The model that we use for the better accuracy and predictability is random forest, as it uses the method bagging method. I think so, boosting or bagging. It's one of the ensemble methods. Has various decision trees, but it predicts the decision tree which has the majority things, and we have so many benefits like cost of risk, expected loss, returns, and level of risk, liquidity. So in summary, so you know what, the returns, level of risk. So that's it. Thank you guys, and this is our team. Now, going into the code, as we are here, have got the data set, the data frame, and we null values were dropped, and we imported numpy for if there are any null values for isnan. So you can see the percentage of missing values, and you can see if the person missing is greater than 80, then let's what's the shape of the data frame. As you can see, this is 1861 rows and two columns. So they have 1861 attributes, which are more than 80% missing values. We need to drop them out. So we should fill the null values and drop the null values too. So we have removed some columns which have more than 80% missing values, so that it's good to decompose it. And so no, you know what, the data set will contain accurate values and good values rather than missing values. So removing the missing values is a good thing. And now we have actually by iLock we got the DFF and Y value, and here we know that this this one indicates it returns the true value if it has none values. Now the data, we have converted the DFF or the data frame to CSV and data.csv. So we have been reading the data frame in the Dask format. This is the data form, sorry, data frame, and we'll be converting into the array, and then we are standardizing the data scaled, and now we'll be liking to decompose the data too, because it's very huge amount of data. Decomposing it will give us good values, as more the data will lead to overfitting. But as random forest doesn't care, is actually against overfitting, it won't affect. Random forest model don't affect overfitting, but the model which we have trained will contain good data. So for we have used the truncated SVD, which is the decomposition, singular value decomposition. And as you know, we'll be performing this following operations. And it's the final data frame head. uh, the X-ray sampled the data, like importing the random under sampler. So these are all the step-by-step methods. And now we will get the class distribution, and again we'll be reading the test file. With that, we got the training data and we trained it. Now we have to test it with the test file. So we'll be dropping ID again. We'll get the var columns, percentage missings, and so many how to do it. And we use the standardizing the data method, which is scaling the data method, which is min max scaler. And we see the matplotlib, the graph, which is a transformation of the test file. Now we have the final data frame and the x3 sample.head. So you can see that. And you can see the graph. These are all errors. We didn't import the warnings or ignore errors, so it actually get a warning. So this is the maximum that an economy. So it's a training and testing data. The depth it's matching about the graph, and now it is a random forest classifier. We are importing with the ensemble method. As we said, it contains ensemble methods like bagging and boosting. And we are fitting the model, training it, fitting the training values. And now we get, that's it. So now we have got the predictor and predictor probability too, as we know. But in the submission file, we have to also you get the ID. So the three columns are there. So our final goal is done, and we have submitted the file. Thank you so much. And we also made a repository, a video demo, and a PPT to get a more overview of the project and how we did it. Thanks to our team, thanks to the Fibe Hackathon for conducting this hackathon. This helped us uh, updating our knowledge about machine learning and trying various ways to help more and upgrade the technology, how the technology works, and it's brilliant. And how the loan and default works, as we got the final data head, the predictor probability as one means true, zero means false, as final. So we are going to submit it. Thank you so much for conducting the hackathon. Thank you. I'm Surya, and this is the team. Thank you.